Welcome to Warriors of the World. Today we'll be exploring Leonardo da Vinci's remarkable military innovations that were centuries ahead of their time. Subscribe now to join our community and support this project. Now, let's begin. When most people hear the name Leonardo da Vinci, they immediately think of the Mona Lisa or the Last Supper. However, what many do not realize is that Leonardo considered himself primarily an engineer rather than an artist. Born in 1452 in Vinci, Italy, Leonardo lived during one of the most violent periods of the Italian Renaissance, when city-states were in constant conflict. According to Martin Kemp, professor emeritus at Oxford University and leading Leonardo scholar, this environment of perpetual warfare profoundly shaped Leonardo's career. The notebooks that survive today, particularly the Codex Atlanticus preserved in the Biblioteca Ambrosiana in Milan, reveal that approximately 25% of Leonardo's drawings were dedicated to military engineering. Domnina Dizon Raymond from the Leonardo da Vinci Society notes that while his artistic works earned him fame, it was his engineering talents that secured his employment with powerful patrons like Ludovico Sforza of Milan. Leonardo's letter of application to Ludovico in 1482 barely mentioned artistic abilities. Instead, as detailed by historian Paolo Galluzzi, director of the Museo Galileo in Florence, Leonardo emphasized his capacity to build portable bridges, drain moats, construct bombardment machines, and design vehicles for breaking enemy lines. This self-marketing as a military engineer worked, and Leonardo spent 17 years in Milan primarily developing military technology. What made Leonardo unique among military engineers of his time was his scientific approach. Unlike contemporaries who worked through trial and error, Leonardo sought to understand underlying principles. According to Pascal Brioist of Tours University, Leonardo systematically studied the mechanics of weaponry, human and animal anatomy for improved movement, material properties for better structures, and fluid dynamics for hydraulic weapons. Leonardo also stood apart due to his intense focus on humanizing warfare. Biblioteca Leonardiana director Marino Franzoni notes that while Leonardo designed devastating weapons, his notebooks revealed deep concern about human suffering. Leonardo wrote that he would not publish certain designs because they were too cruel, showing a remarkable ethical awareness unusual for his era. The historical context of Leonardo's military career coincided with transformative changes in warfare. The introduction of gunpowder weapons to European battlefields had rendered traditional medieval fortifications obsolete. The Franco-Italian Wars, beginning in 1494, created an arms race among Italian states desperately developing new military technologies. Leonardo stood at this critical juncture, reimagining military engineering for a new age of warfare. Perhaps Leonardo's most visionary military concept was his armored war carriage, widely recognized today as the world's first tank design. Sketched around 1487 in his notebooks now preserved in the British Museum, this remarkable invention anticipated battlefield mechanization by over 4 centuries. The design, as analyzed by engineer and Leonardo specialist Mario Tatti, featured a conical wooden structure reinforced with metal plates. The vehicle was approximately 8 feet high and 20 feet in diameter, providing substantial protection for the soldiers inside. Unlike horse-drawn war chariots of previous eras, Leonardo's tank was designed to be powered by human operators using a hand crank system connected to geared wheels. What made this design revolutionary was its offensive and defensive integration. The armored shell protected its occupants while they operated light cannons positioned around the vehicle's circumference, allowing 360-degree firing capability. According to military historian Everett Wheeler, this represented the first comprehensive design combining crew protection, mobility, and offensive firepower in a single platform. Modern reconstructions of the design by the Museum of Science and Technology in Milan revealed one critical flaw in Leonardo's original drawings. He depicted the cranks operating in opposite directions, which would have caused the tank to spin rather than move forward. As noted by historian Domenico Lorenza, this error was likely intentional. Leonardo expressed concerns about warfare's destructive power and occasionally introduced deliberate mistakes into his most dangerous designs. Among Leonardo's most forward-thinking military designs were his multi-barrel weapons that prefigured machine gun development by centuries. His 33-barrel organ, sketched around 1480 in the Madrid Codices, represented a revolutionary approach to increasing firepower. As weapons historian Bert Hall describes, Leonardo arranged 3 banks of 11 small-caliber gun barrels in a triangular configuration. This arrangement allowed for unprecedented sustained fire capability, as one row could be fired while another cooled and the third was reloaded. According to findings by researchers at the Leonardo Museum in Vinci, this weapon could theoretically achieve a rate of fire approaching 100 rounds per minute, dramatically exceeding the 2 to 3 rounds per minute possible with standard firearms of the era. This concept of sustained fire through multiple barrels directly anticipates the Gatling gun of the 19th century. Beyond multi-barrel weapons, Leonardo pioneered fragmentation explosives designed to maximize casualties. The Codex Atlanticus contains designs for what Leonardo called a bombardment shell, essentially a hollow brass sphere filled with smaller pellets and explosives. Military archaeologist Kelly DeVries notes striking similarities between these designs and modern fragmentation grenades developed 4 centuries later. Leonardo also developed primitive versions of missiles and cluster bombs. His notebooks detail projectiles with stabilizing fins that would be launched from cannons but with extended range due to their aerodynamic properties. As weapons technology specialist Filippo Camerota explains, this design principle underlies all modern rocket artillery. Among Leonardo's most visually striking military designs is his giant crossbow or grande balestra, a weapon of psychological as well as physical impact. This enormous weapon, detailed in the Codex Atlanticus around 1489, was designed to launch stone projectiles or possibly incendiary materials against enemy formations and fortifications. According to reconstructions guided by Leonardo specialist Alexander Newell, the crossbow measured approximately 42 feet wide with a firing mechanism requiring multiple operators. What made this weapon particularly notable was its mechanical sophistication. As detailed by engineer Louis Borelli, the weapon utilized both the flex of the bow arms and the tension of spiral springs to generate unprecedented projectile velocity, potentially launching stones weighing up to 70 pounds. The exact tactical purpose of this oversized weapon remains debated among military historians. Matthew Landris of Oxford University suggests it may have been designed more as a psychological weapon than for practical battlefield use, as its imposing appearance would have had a demoralizing effect on opposing forces. Leonardo's siege weapon innovations extended beyond the giant crossbow. His notebooks contain numerous designs for trebuchets with counterweight systems superior to medieval versions. According to mechanical engineering professor Matt Doherty, Leonardo's improvements included adjustable counterweights for range control and special mounting systems that absorbed recoil energy, allowing for faster reload times. Particularly innovative was Leonardo's design for what he called the continuous catapult. This device, analyzed by the Leonardo da Vinci Museum in Venice, utilized a series of spring mechanisms and a conveyor system to load and fire projectiles in rapid succession without the lengthy reloading time typical of traditional catapults. Leonardo's contributions to defensive military architecture represented some of his most practical and immediately applicable innovations. Living during a period when traditional medieval fortifications were being rendered obsolete by cannon fire, Leonardo developed revolutionary defensive designs that military historian Simon Pepper describes as anticipating developments in fortification by nearly a century. The key insight in Leonardo's defensive architecture was his understanding of ballistics. Traditional vertical castle walls provided perfect targets for cannonballs. Leonardo's solution, rounded or angled bastions designed to deflect projectiles rather than absorb their impact directly. According to architectural historian Horst de la Croix, these designs preceded the widespread adoption of angular bastion systems by significant margin. Leonardo's star-shaped fortress designs, particularly evident in his plans for the city of Piombino created around 1502, incorporated interlocking fields of fire that eliminated blind spots where attackers could find cover. Military engineer Jean-François Pernot notes that these principles became fundamental to the later Tres Italienne fortification style that dominated European defensive architecture for 3 centuries. Modern archaeological studies directed by Francesco Paolo Fiori at sites where Leonardo consulted have uncovered evidence that his defensive recommendations were partially implemented, making these among his few military designs to see practical application during his lifetime. Leonardo's military engineering genius extended beyond land warfare into revolutionary naval and underwater combat systems. Among his most forward-thinking designs was Leonardo's diving apparatus, detailed in the Codex Arundel preserved in the British Library. This early diving suit, analyzed by marine technology historian Margaret Rule, consisted of a leather diving suit with a cane snorkel system and brass rings to maintain rigidity. The military applications Leonardo envisioned for this diving technology were remarkably sophisticated. His notebooks describe how divers equipped with his apparatus could approach enemy ships undetected and use handheld drills to bore holes in their hulls. According to maritime archaeologist George Bass, This concept of combat swimmers engaging in underwater sabotage represents the first documented conception of special naval operations. Leonardo also designed primitive submarines or semi-submersible vessels. Maritime engineering professor Carlo Beltram notes that Leonardo's submersible design featured ballast tanks that could be filled or emptied to control depth, the exact principle used in modern submarines. Though materials technology of Leonardo's era could not support practical construction, the conceptual framework was sound. For surface naval warfare, Leonardo developed early concepts of the ironclad warship. His designs show vessels with reinforced hulls designed to withstand cannon fire, a concept not successfully implemented until the American Civil War over 3 centuries later. Naval historian Richard Woodman observes that Leonardo's understanding of the vulnerability of wooden ships to artillery preceded actual battlefield experience with naval artillery by decades. Particularly innovative was Leonardo's design for a paddle-wheel ship powered by human operators using a complex gearing system similar to that in his tank design. The paddle-wheel concept, as marine propulsion specialist Adrian Osler notes, represented a significant improvement over traditional oar propulsion by allowing fewer men to generate more propulsive force. Leonardo also developed specialized naval weapons, including multiple rocket launchers designed to be mounted on ships and fire incendiary projectiles against enemy vessels. According to weapons historian Alex Rowland, these designs anticipate naval rocket systems developed in the 18th and 19th centuries. Some of Leonardo's most practical military contributions involved improved battlefield mobility and logistics. Military historian Martin van Creveld notes that throughout history, armies have often been defeated more by logistical failures than by enemy action, a reality Leonardo seemed to understand intuitively. Leonardo's famous swing bridge design, sketched around 1488, represented a revolutionary approach to military mobility. This rapidly deployable bridge could be transported by an army on the move and quickly installed to cross rivers or ravines. Engineering historian Andrea Matthees observes that the bridge's counterweight system allowed it to be raised or lowered by just a few soldiers, unlike traditional bridges requiring extensive construction teams. According to reconstruction efforts at the Leonardo da Vinci Museum in Florence, the bridge could span approximately 40 feet and be deployed in under 2 hours, providing tactical advantages for armies needing to maneuver rapidly. The basic principles of Leonardo's design directly anticipated modern military portable bridges used by combat engineers since World War II. Leonardo also designed improved transportation systems for artillery, historically one of the most logistically challenging aspects of Renaissance warfare. His notebooks contain designs for modular cannon carriages that could be disassembled for transport over difficult terrain and quickly reassembled for battle. Artillery historian Bert Hall notes that this concept of modular weapon transport was not fully implemented until the 19th century. Particularly innovative were Leonardo's designs for amphibious vehicles. The Codex Atlanticus contains sketches of wagons with sealed wheels designed to function both on land and as pontoons for water crossing. According to military technology specialist Simon Werrett, these vehicles anticipated modern amphibious assault vehicles by 5 centuries. A crucial but often overlooked aspect of Leonardo's military designs was their foundation in his revolutionary anatomical studies. Unlike most engineers of his era who approached mechanism design purely from mechanical principles, Leonardo uniquely understood the parallels between biological and mechanical systems. This biological inspiration led to innovations that were centuries ahead of their time. Leonardo's anatomical work was not a separate pursuit from his engineering but integral to it. As anatomical historian Domenico Lorenza explains, Leonardo believed that nature had already solved many of the mechanical problems he was attempting to address in his military designs. His studies of muscle systems directly influenced his weapons designs. According to biomechanical engineering professor Michael Gaffari, Leonardo's understanding of how muscles generate power through contraction and leverage informed his designs for torsion catapults and spring-powered weapons. The repeating crossbow mechanism Leonardo designed closely mimics the biomechanical principles he observed in the human arm. The defensive armor and mobile fortification designs in Leonardo's notebooks reveal inspiration from his studies of crustaceans, tortoises, and armadillos. Military technology historian Lynn White Jr. points out that Leonardo's tank designs incorporated overlapping plates similar to those he documented in his studies of arthropod exoskeletons. Perhaps most innovative was Leonardo's application of fluid dynamics learned from his studies of the human circulatory system. His designs for hydraulic weapons and canal defense systems reflect principles he documented in his studies of blood vessels and heart valves. Bioengineering specialist Fritjof Capra observes that Leonardo uniquely understood how fluid pressure could be regulated and directed through variously sized channels. Despite the brilliance of Leonardo's military designs, very few were constructed during his lifetime, raising the question of why such innovative concepts failed to materialize. This gap between conception and implementation offers fascinating insights into both Renaissance technology and Leonardo's complex relationship with warfare. One primary obstacle was the material limitations of the 15th century. According to engineering historian Bert Hall, many of Leonardo's designs required precision metallurgy, standardized parts, and power sources that simply did not exist until the Industrial Revolution. His tank concept, for instance, required drive mechanisms that would not become practical until the development of internal combustion engines 4 centuries later. Manufacturing precision presented another barrier. Leonardo specialist Paolo Galluzzi notes that the tolerance levels in Leonardo's gear systems and weapons mechanisms required machining capabilities that would not exist until the 18th century. Modern reconstructions of his designs often require computer-controlled manufacturing to achieve the precision his sketches specify. Economic factors also limited implementation. Military economics historian Frederick Lane calculates that building even one of Leonardo's larger war machines would have cost the equivalent of maintaining a company of soldiers for a year. Renaissance rulers, operating with limited treasuries and immediate threats, rarely could justify such experimental expenditures without guaranteed results. Technological secrecy created additional barriers. As military technology specialist Pamela Long documents, military engineers typically worked in environments of extreme secrecy. Leonardo himself wrote in mirror script partly to protect his ideas from casual readers. This secretive culture inhibited the collaborative refinement necessary to move from concept to practical implementation. Institutional resistance may have been another factor. Cambridge University historian Simon Schaefer points out that military organizations throughout history have typically resisted revolutionary innovations that might disrupt established tactical doctrines and power structures. Leonardo's designs would have required completely new training regimens and battlefield tactics that existing military leaders might have viewed with skepticism. Perhaps most intriguing are the ethical reservations that appear in Leonardo's own writings. In notes accompanying some of his most destructive designs, Leonardo expressed moral concerns about their implementation. Military ethicist Martin Cook suggests these expressions reflect Leonardo's internal conflict between his engineering genius and humanitarian instincts. Leonardo famously wrote of one underwater breathing apparatus that he would not publish its details because it could be used for evil, suggesting self-censorship of some military innovations. Despite these implementation challenges, Leonardo's military designs had profound long-term influence. Military historian Alex Rowland documents how Leonardo's concepts circulated through European engineering circles via copies of his manuscripts, influencing subsequent generations of military engineers. Concepts like angled fortifications, modular weapons, and mechanized vehicles eventually became standard, though rarely attributed to their original conceptual source. Modern reconstructions have validated many of Leonardo's concepts. The British Army's Royal Engineers constructed a working version of Leonardo's self-supporting bridge in 2000, confirming its viability with Renaissance materials. Similarly, teams at the Massachusetts Institute of Technology have demonstrated the mechanical feasibility of Leonardo's robotic knight using only technologies available in the 15th century. Leonardo's approach to military engineering remains his most enduring legacy. As historian of technology Thomas Kuhn observed, Leonardo pioneered the integration of scientific understanding with practical design, developing what we would now call an engineering methodology. This systematic approach to analyzing problems, testing solutions, and documenting results transformed military engineering from a craft tradition to a scientific discipline. Subscribe now, become a member, turn on notifications, share this video with your friends, and leave a comment so we can compare our knowledge and sources. Thank you for following our channel. Until our next strategic journey, here at Warriors of the World.